All right, so taking to an extreme, the person in front of the train. So train is going to hit a person at 60 miles per hour. The amount of force acting on the person is going to be about 1,000,000 pounds. So what do you think is going to happen to the person? Will the person splat, or the person is going to fly like a constipated bird? What do you think? Have you ever seen anyone get hit by a train in real life? All right, guys, we live in the Chicago area. It happens once or twice a year. It's a common thing, evidently. And sometimes people report seeing people getting hit by a train. All right, and when you do get hit by a train, I got news for you. You're not going to splat. It's just a myth. 1,000,000 pounds of force acting on you, which means that you will splatter all over the place, especially if the train is going at 60 miles per hour. So torso goes one way, the legs, the arms, it just splatters all over the place. Now, no one denies that something bad happens to the person. All right, if 1,000,000 pounds of force acting on the person, that implies that according to Newton's third law, person should also get to apply the same force back on the train. So the question is, does he really? Where's the evidence? I mean, you saw the person getting hit by a car. You saw the evidence on the car, guys. You saw the evidence on the car. The car got dented. If you're inside the car, you actually felt the jerk of the impact. But if you're on the train, it's not the same. You're reading a book, newspaper, texting someone. I don't know what you guys do usually on the train. If a train hits a person, if you're on the train, unless you see it happen, you will not even notice it. All right. If you see anything, you're probably going to end up seeing a head flying by. When was the last time you saw a head flying by? Hopefully never. You're not going to think to yourself, gee, I think we just hit someone because I saw a head flying by. You're going to think to yourself, look at that ball, which has a face on it. Now that the Halloween is coming up, I wonder where I could get one of those. That's your thinking pattern. So how is it that the person applies the same force back in the train, yet you don't feel it? It's 1,000,000 pounds of force, guys. How does that even work? How does that even work out?
So the force is equal to mass times acceleration, right? So then, since the train is so massive, the acceleration will be minuscule in comparison.
Okay. Yeah, give yourself 10 points for that one. That's not a bad way of looking at it. So let me make it a little bit more dramatic because that's what I like to do. So that when you're having a nightmare, there's a reason for it. All right. All right. Let's get back to the same question. Person getting hit by a train, right? That's what we were focusing on. All right. So here's what you need to know. All right. So here's the train, the mass of the train. I tried to make it as big as possible. It's growing. It's growing. Cool. All right. Train is really, 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 really massive. All right. So here's the mass of the train. I'm going to put a big M in the middle. So the train is really, really, really massive. And in front of the train, I'm going to put your mass. Okay. So I'll just put you right here somewhere. And this is you. Oh my God. This is so cute. All right. Is it even going to let me make this? Okay. So let me check to see if this works. Ah, this is you. That's awesome. All right. So here's the action force acting on you. This is going to be 1,000,000 pounds of action force. All right. So this is action force acting on you. And the same force is going to be acting on the train. It becomes a reaction force in the opposite direction. All right. So reaction force is acting on the train. All right. So here's your mass. Okay. Let me just put your mass. I cannot put the mass inside. We got to make it very tiny. All right. So here's your mass. Do you see your mass? Oh, beautiful. This is your mass. And this is the mass of the train. All right. So what's happening is action force is acting on you. All right. So this is your mass. Okay. So we got to just make this as big as possible. All right. So this is your mass. It's very small. And so the action force is going to be acting on it. Let me just get here. Action and reaction forces are the same. And let's get out. That's your mass. And here's the mass of the train. This is humongous. So as it so happens, because your mass is so little, your acceleration is going to be huge. This is your acceleration. All right, so this is the A. Small mass is going to accelerate. And the acceleration of the train is going to be extremely small as it so happens. All right, so the acceleration of the train is going to be very small. It's right here. Guys, forces are the same. Notice that the smaller mass is going to undergo the biggest acceleration. Literally, your body is going to go from 0 to 120 miles per hour within a fraction of a second. Train is probably about 50 million pounds, guys. 1,000,000 pounds of force acting on it for a fraction of a second is going to cause a very small acceleration. Acceleration is going to be so small that the train is going to go, literally, it's going to go from 60 miles per hour to 59.9999 miles per hour for a fraction of a second. What does that feel like? It feels like a vibration. It feels like a vibration. Does the train ever vibrate? Of course it does, all the time. All right, so your life would be one of those vibrations. All right, that's the contribution of your life to the motion of the train. It's nothing. Acceleration is going to be so small, it's unnoticeably small. So Newton's third law still holds. For every single action force, there's going to be an opposite, equal and opposite reaction force, except the force acting on something which is so massive and the duration of the force is so short, it just causes an unnoticeably small acceleration. All right, so those people who made that comment, remark, give yourself 20 points. Okay, so that's the reason why. So that's what you would expect to see. Mathematically, it's going to work out the same way. All right, so in terms of math, here's what I want to do. All right, so there are a couple of problems that I want you guys to focus on. So let me just take you to the mathematics. All right, this is not the right one. Chapter number 4, mathematics. So let's just open this up. Concepts, the math problems. All right, so the stuff that I want you to do while you guys are getting ready for the test. All right, this is an easy problem, so work it out. If it's green, okay, so while you're studying for the test, focus on that one. Now focus on this one. These are test quality questions. All right, the one that we're going to be doing in class is this one. Oh my God, this is so cute. This is the one that we're doing in class. And the one that we're doing in class is literally a person getting hit by a train. Impact is going to last 1/100th of a second. In reality, it's going to last about 1,000th of a second. And then, so let's figure out the acceleration of the person as well as the train, and then figure out the speed of the person and the train right after impact.